this function just because we made a function doesn't mean we're using the function, right? So every time you write something, you should have a test script. Meaning, what values will you have and what values do you expect to return? So for instance, if I make A equals 2, B equals 5, and C equals 3, so you'll get 2 plus 3 is 6, 24, so that's 1. So 24 divided by 4. Wait a minute, am I doing this right? So 25, this is 24, so this is 1, right? So minus 5 minus 1 will be negative 6 divided by 4. So x1 will be negative 1.5 and x2 will be, so if I add 4 divided by, wait, I'm confused. Oh, 1, right? Negative 1. So those are the two values, right? If you enter those values, that's what you will expect. So, in my main, I'm gonna run out of space here. So in my main, I have an int main. And you will ask the user all those things. The bottom is just return 1. Return 0. So, in the variable declaration, I said you should have one variable for each input from the user and one variable for each output. I'm gonna deviate a little bit from the names. I'm gonna select 5. So I'm just gonna call them A, B, C, comma, X1, comma, X2. I know I told you put the double to know that, but I'm gonna name them just like that for right now. Also, I put them in caps letters when you know that caps means constants, but be patient. So you go ask the user, let's see, for the values A, B, C. And the user entered those values. So A equals 2. I'm gonna put them next here so you can see from the back. Okay. So that's what the user entered. So this is your declaration, this is the input. And then, in the if statement, inside an if statement, I could put a variable type Boolean, right? I could put the word true or false, or I can write an expression that returns true or false, or I can use a function that returns true or false. Let me make some room here. For now, make our life easier, I'm gonna make a variable. And I'm gonna call it success. Is that how you spell success, with 2 C's?
Yes.
Alright. I don't know if the success is true or false. So, your calculation section, it says success equals, well, I need a function that, or an expression. Well, there's a function called quad that takes ABC, which I have, A, B, C, those are values, right? I could even hard code the numbers here. But then the next two parameters, also known as out parameters, they are pointers. So I didn't declare any pointers here, but it's expecting pointers there. So in the scanf function, for instance, you don't declare a pointer to whatever variable you pass. You just pass the address. How do you pass the address? The and sign, right? So the and sign of x1 and the and sign of x2. That means I pass the address. Now my main is kinda small. I can do if statement, and if it was successful, I can just write print f, and we use you can format it too if you want. So x1 equals percentage, I'm gonna use 0.1 float, comma, x2 equals 0.1 float, new line, x1, comma, x2. Otherwise, just print an error message. So look at my main, it's very short. And that should work. So this is the same way, I'm sorry, here. Same way as the scanf works. You pass the address. Basically the scanf has a pointer. So if you write this in Visual Studio, it should work. So let's change our operating system to a 64-bit for now. And let's see what happens in memory. when you run your program. All right, let's trace this program. My computer is going to start at the main, right? The first point of entry. So it starts at the main. And in the main, I declare variable type Boolean, okay, called success. So here is going to be Boolean success. I'm going to use that address. It's going to allocate 64 bits because we said we're going to change it to 64-bit operating system. Although it's only going to use 1 bit, it's going to allocate all 64. Then I declare 5 doubles, right? So I declare, I'm going to run out of room here. And I need more room. Write it down here. So it would be 0, 40, 36, right? 36. So 264 minus 93.6 plus 86, 87. It's not like this. Hopefully I have enough room. So I start declaring a Boolean, goes here, and I call that success. Next line, yes?
Because I get sort of confused when it's a Boolean, it's one integer, or one bit. And the whole thing is 64-bit?
Because that's all it can allocate. It cannot allocate more or less. Always allocate 64-bit chunks.
That means that the Boolean is somehow 64 bits?
Yeah, you just wait 63 bits.
Okay.
So the next line, this line, maybe I should number them. So let's do this. I assume I have my include math.h. So let's say this is line 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. So those are are my line numbers. So I was in line 22, now I'm moving to line 23. So I'm here. So line 23 says declare 5 doubles. So I do double 1, 2, 3, 4, 5. So it goes A, B, C, X1, X2. That's what I declare here. And they have garbage inside, right? You don't know what they have. Line 23, line 24 gives the value for A, B, C. So A is 2, 2.0 actually, 5.0 and 3.0. Like your GPA. No, yours is 4.0, right? Alright, so next line, line 25. This is the, pay attention to this. So the computer is gonna see the equal sign, right? And then it doesn't know what's on the left, it's gonna do the expression on the right. And the expression on the right says, there's a function called quad, like the quad processors. That takes 5 parameters. 3 are doubles, and 2 are pointers to doubles. So what it's going to do here, it's going to do this. It's going to declare the function Boolean called quad right here. And I don't know what the return value is. But that quad function uses 5 values. So I declare those double, but okay, double, I call this a little different. I call this one DBL-A, DBL-B, DBL-C, but these ones are pointers, so I'm gonna put a star here. And I don't fit here, but I'm gonna put double X1, double X2. Those are the parameters that that function takes. And then these ones are just regular primitive types. So we say we pass a value to the function. So let's pass by value. That's important. So, right, A lines up with double A, B lines up with double B, and C lines up with double C. So it's gonna do this. A, B, and C. So it copies the content of A and puts it in double A. So that's why it's passed by value. It copies the values. And these ones are pointers. And we didn't pass the value of x1 or x2 because actually it has garbage. We pass the address. So the address of x1 is 0872, so we pass that address, right? And then the next one is that's what we pass. That's why you pass in the scanf function, you pass the address using the and sign. So far so good? Alright, now I go up to line 11. Now I'm inside the function. I am in the body of the function. And I declare a double here. Right? And I call this square part. double square part. And I do this method. 5 times 5 is 25, minus 4 times 2 is 8, times 3 is 24, so the square part is 1, right? Oh, and now go to line 12. I'm here now. And I said declare a Boolean. Call it red. And give it a value of true. Now I go to line 13 and it says is double A equals 0? Double A equals 0, no, it's 2. Is the square part less than 0? No. It's 1. Then this thing is false, right? So go to the else part. And the else part says there's an equal sign, so evaluate the right side. So the first one is going to be negative 1.5. Actually be 1 and the second is negative 1.5, it doesn't matter. So in here I use the star to say go to that pointer. Double x1, here's double x1, right? That has the value 0.872. So go there and put the value, this expression, which is going to be negative 1.5. Or it will be negative 1 actually. So 872, where is 872? Right here is 872. Put the value here, negative 1.0. And goes to the next line, line 17. Evaluate the right side, that's negative 1.5. And then, oh, there's an equal sign. What does that equal sign has on the left? It has the value of variable double x2. Where's double x2? Oh, right here. Because it's a pointer, double x2 says, go to that address. Where is 936? So it's right here. All right, so here's 1.5. And I'm done with the end. Then it says, oh, return the value of this variable, right? So it goes here, where is return, goes to wherever I declare that function that is here. And it says return the value of this variable. That variable is there, it's true. So I go here. And then it says the curly bracket. X is the function. And it goes back here, right? Because that's where I call that function from. Line 25. And at that point, when I see this curly bracket, the computer is gonna release all this back to the operating system. Because all these variables were treated as local variables. And now I'm here. Now I go back to the equal sign. Success equals this quad. Well, quad is big. Oh, I erased it. Quad is true. So here's that variable success. I'm going to change that to whatever that value is. And then this is done. I don't need it anymore. And I am left, when I'm at the if statement, I'm left with just distinct memory. And that is easy. I just, if it's success, then print. It's one of the next two. If you fail, then we don't care about what the values have, we just print an error message. And that's how this sequence of events happen. Did it make sense? Yes.
But the speed is different on the 64 bit still?
No.
No.
speed is the same. That's measured by how many, well,
Yeah. How well
the speed, no, it's basically your front bus is what determines how many bits you can carry from the CPU to the RAM. You will not notice the difference, of course.
Okay.
But if you don't have a limit that low of memory, then 64-bit will be faster. Yes?
We use the phone in this case just to, or primarily to change those, that X1 and X2 in another function.
Yeah.
And then so we could get more outputs out of the same.
Yeah, this is the exact same way the scanf works. You pass just the address. So you, in essence, you return three things, right? Actually, you return one and modify the other two from the calling object. Bless you. Because we modify this, and these are pointers. This is a question in the exam. We call this pass by reference. Every time you pass an address to a method, you're passing a reference. When you just pass the value here, you can change A, double B, it will not change these values, right? You change this too, because those are pointers, it will change this too. And we just saw how. That's called pass by reference. Questions? Yeah.
And the CPU, the CPU is the front bus.
No, the front bus is simply how many wires are in your motherboard from the CPU to whatever device.
Oh.
It's like highway lanes if you think of it. Any other questions? All right, so it's a lot to take in, I know. And from here until the end of the semester, we're going to be working with pointers most of the time. So you better get used to them. And then when you transfer to, or you take the next class, so you're going to see pointers. We call them classes though, but they work the same way. So, all right, well then that's it for today. Yes? Let me turn this off.